Hi everyone and welcome back to my channel in Economist. So in the previous video I have covered what is continuity of a function. Now it's time for us to learn about the differentiability. If you haven't watched my previous video, I will give the link in the description box. Please see the video on continuity first so that you understand differentiability. Let me start with the concept of derivative. What is derivative of a function? Suppose f is a real function and c is a point in its domain. The derivative of function f at the point c will be defined in the following way. Limit h tends to 0 f of c plus h minus fc upon h provided the limit exists. Now let me explain to you what is it's all about. Suppose this is x-axis, this is y-axis, and you have a function like this, fx. Fx is your function and you have a point in your domain as this, x is c, right? So if you join this, you are talking about this point in the function. So this is the point fc, right? This is the point fc in your function. Now what is the derivative of the function at point c? Derivative is nothing but the slope of the function at this particular point. So slope is denoted as this. If you join by a line segment, let me do that. Yes. So if you draw this line segment which passes through the line, which passes through the point x equals to c here, then the slope of this particular, the slope, that is the angle that is being created at the center, will be nothing but the derivative of the function at that particular point c. I hope this point is clear. So derivative is nothing but the slope of the function at that particular point, and it is, in other words, if you want to know, it is the instantaneous rate of change of the function with respect to the dependent variable. You can remember this. It is the derivative is nothing but the instantaneous rate of change. So slope is nothing but the rate of change. So if you look at this numerator, it is f of c plus h minus fc. So it is showing you how this functional value changes as this value goes towards x equals to c, right? So that is what the derivative is. It is the instantaneous rate of change of the dependent variable when you take any point in the domain of the function. So that is what is derivative. Now if you go into a little more detail, what you have is that in general the function is defined in the following way. If prime x derivative, if you have done in your high school, you have probably seen this. If prime x derivative is denoted as this, or you can also write in this way ddx of fx, or it is y prime, any which ways you can write it. So f prime x is nothing but limit h tends to 0 f of x plus h minus fx upon h. This is the formula of the derivative. It's just showing the rate of change, and the process of finding the derivative of a function is called the differentiation. And we also use the phrase differentiate fx with respect to x to find the f prime x. So f prime x basically means that you want to differentiate the function fx with respect to x, right? With respect to a point in the domain of the function. So you write it in this way, dy dx. So you are basically saying how the variable y will be changed if you change your x. D basically represents a very small change. D means very small change. Sometimes you call it as delta. So you write it as delta y upon delta x. Delta implies the small change. So if you change your variable x by a very small amount, what will be the change in your dependent variable, that is the variable y. That is what is meant by the derivative of a function. Okay. Now these are some of the rules of derivative. I hope that you know this already, but still for revision I have given this. The following rules were established as a part of algebra of derivatives. So the first rule is the summation rule and the subtraction rule, that is u plus minus v prime. That is, if you take the derivative of this kind of a function, you can separate the functions out and take the derivative individually. So u prime plus minus v prime. This is the product rule. This is also known as the Leibniz rule. So u v prime is u prime v plus u v prime. And this is the quotient rule, is u upon v prime is u prime v minus u v prime upon v square. We will solve question on this. We will see this in a while. And these are some of the standard functions derivatives. So x to the power n, if your function is in this format, the derivative will be n into x to the power n minus 1. We can prove the these rules, but as of now I know that you know all this, so I haven't gone into details of that. For trigonometric functions, these are the derivatives. Sin x has the derivatives cos x. Cos x is minus sin x and tan x is sec square x. Right? Okay. Now let us see how to check for the differentiability at a point x equals to e. How do you check the function is differentiable or not at a particular point x equals to a? For that, what you have to do, you have to calculate something called the left hand derivative at the point x equals to a, and you have to find the right hand derivative at the point x equals to e. And this is the formula for that, and this is the most crucial formula in this chapter. Every question you will solve will be dependent on these two things. You must know how to find out the left hand derivative and the right hand derivative. So look at this formula carefully. Limit, so f prime a plus means the right hand derivative of, a plus means in the limiting sense, you are approaching a from the right hand side, right? This is a plus, so it can be found out in this fashion. Limit h tends to 0 f of a plus h minus f a upon h, and we are assuming that this limit exists and it is finite where h is greater than 0. H cannot be less than 0. H cannot be negative. And again, for the negative side, or you are approaching a from the left hand side, you have to find this expression. Limit h tends to 0 f of a minus h minus f a upon minus h. Right? Again, provided the limit exists and it is finite, h is greater than 0. And if you see that the left hand derivative at x equals to a is equals to right hand derivative at x equals to a, only then you will say that, and it's a finite quantity, then you will say that the derivative exists, derivative of the function f exists at the point x equals to e. And the right hand derivative and the left hand derivative is also denoted as this. Right? So we'll see in a while how to solve questions using this expressions. Now before going into the question, I wanted to discuss with you this particular theorem, which is very important, that if a function, this is a very important theorem, you must know this, that if a function fx is derivable at x equals to a, the function is continuous at x equals to a. That is, every differentiable function is continuous. So it is the relationship between continuity and differentiability. That is the reason why I told you to see the video on continuity first. So it basically says that if a function is not continuous, it implies that it cannot be differentiable, right? If a function is not continuous, the function cannot be differentiable. In other words, every differentiable function is continuous, but not the other way around. Every continuous function is not differentiable, but every differentiable function is continuous. So before checking differentiability of any function, you must ensure that the function is continuous. Otherwise, there is no point of checking differentiability. And this is the proof of this theorem. You can take a look at this. It's very simple, that you start with the definition of the differentiation, that f prime a. F prime a is the differentiation of the function f at the point x equals to a. So this is the formula. Limit h tends to 0 f of a plus h minus f a upon h, and this exists because we are assuming that the function is derivable. And then starting from this, you have to show that the function is continuous also. Let's see how to do this. Take this portion first. Take only the numerator, and this numerator can be written in this form. This is as it is. You are multiplying this expression by age upon age. So you are multiplying one age and you are dividing by one age, right? Now you take the limit on both sides. If you take the limit, this limit will give you f prime a, right? This is what we have started with. And this limit is, since this is in the product rule, you have to apply limit to this expression also. So limit h tends to 0, h is 0. So altogether this expression is 0. So we have got that limit h tends to 0, f of a plus h minus f a is 0. And if you take this on the right hand side, if a, since it is independent of h, you can, take it to the right hand side and you will get this. The limit is equals to the value of the function, and that is the definition of continuity of a function at a particular point x equals to a. Hence, we have proved that fx is continuous at x equals to a. And this is a very crucial thing, and you will see that it has an application in your questions also. Let's solve this question, you will understand by yourself. Okay, so it says that you have a function fx which looks like this, and you have to, and it is given that it is differentiable. So this function is already given to be differentiable, and you have to find the value of a and b. So for which value of a and b this function is differentiable. So what you have to do, you have to find the left hand derivative at x equals to minus 1. What will that be? So find out h tends to minus 1 minus, this will be minus 1 minus h minus f of minus 1 upon minus h. I am just following this formula. Oops, sorry. Let me give you the formula once more. Yeah, this is the formula I am using. If prime a minus s, limit h tends to 0, f of a minus h minus f a upon minus h, right? So here a is minus 1. Here a is minus 1, so you are finding, this will be limit h tends to 0, right? Limit h tends to 0, f of a minus h, a is minus 1 here, a minus h minus f a upon minus h. So calculate this, limit h tends to 0, what will this be? This is from the negative side, yeah. So this will be a minus 1 minus h plus b minus a into minus 1 plus b, right? And here you have minus h, limit h tends to 0. You can cancel this thing, and you have minus a minus ah minus plus a upon minus h. So what you have, h minus a cancels out, so it is a. So the left hand derivative is a. Now let us look at the right hand derivative at x equals to minus 1. What will that be? That will be f of a plus h minus f a upon h. So find that out. Expression is a x cube. So you have a x cube plus x plus 2b plus x plus 2b minus, you have f of minus 1, so a minus 1 cube plus minus 1 plus minus 1 plus 2b, right? Yeah, upon h. Okay, now you need to simplify this expression. Do that. 2b will cancel out. Here you have a h minus 1 cube, then you have minus 1 here and you have plus 1 here, it will cancel out. So plus you have h here minus, and here you have minus a, minus minus plus a, right, upon h. Okay, so what you can do from here is that a into
simplify this. A cube minus 3a squared b plus 3ab squared minus b cube plus h plus a upon h. Okay, let me go to the next page. Limit h tends to 0. Now what you will do, you will apply this h inside. So you will take this h inside and see what you get. Okay, let me write this expression once again. A cube minus 3a square b plus 3ab square minus b cube plus h plus a upon, you have h, right? This is the expression you have. Now put this h inside. So you have a h square minus 3a h plus 3a minus a upon h plus h upon h is 1 plus a upon h. So here if you see, this will cancel out, and if you put the limit here h 0, so this will vanish, and you will be left with this and this. So 3a plus 1. So this is your right hand derivative at x equals to minus 1. Now if you look at this question, this function is derivable, hence the left hand derivative and the right hand derivative has to be equal. Left hand derivative was a and the right hand derivative is this. So if you simplify this, what you will get, 2a is minus 1, right? Take this here. So you have 2a is minus 1 and a is minus 1 upon 2. So this is your value for a. I hope this is clear, this is understood. Okay, now you have to find the value of b as well. How will you do that? For that you have to use the property of continuity. Since this function is differentiable, you know that automatically the function has to be continuous. So find out left hand limit at x equals to minus 1 and find out the right hand limit at x equals to minus 1 and just equate them. That is what you need to do. 1 minus. So find the expression. You have ax plus b. Ax plus b. Put the limits here. So a into minus 1 plus b. So you have minus a plus b. And right hand limit at x equals to minus 1. This is limit x tends to minus 1 plus, and the expression is ax cube plus x plus 2b. Ax cube plus x plus 2b. Now put the limit. Minus 1 cube is minus 1, and then you have minus, here you have again 1, right, plus 2b. Have I done this right? On the right hand side you have ax cube plus x plus 2b. So ax cube, put minus 1 here, minus 1 cube is minus 1, so minus a, minus 1 plus 2b, right? So now just equate these two, minus a plus b, and here you have minus a minus 1 plus 2b, right? Cancel this thing. What do you have here? Take this 1 here and take this b here. So b is 1. So what we have done here is that firstly we have calculated the left hand derivative and the right hand derivative, and we have equated them to get the value of a, which came out to be minus 1/2. And then since the function was differentiable, we have equated the left hand limit with the right hand limit, and we have equated them because from the property of continuity
to get the value of b. So this was a good problem which give you a sense why we have proved the theorem first and then we came into this, right? Okay, let's solve question number 2 now. Show that if x is mod of x minus 3 is continuous but it is not differentiable at x equals to 3. So for continuity, we have done these sort of questions in continuity beforehand. So fx, but before going into that we have to write this function in this way. This is x minus 3 if x is greater equals to 3, and it is minus of x minus 3 if it is less than 3, right? So now you can find out the right hand limit and the left hand limit. So it will be x tends to 3. From the right hand side it is x minus 3. Put the value, it will be 0. Again 3 minus if x is limit x tends to 3 minus of x, excuse me, minus of x plus 3, right? This is the expression. And again if you put the value, it will be 0. So left hand limit is equals to the right hand limit. So if x is continuous at x equals to 3, right? Now we need to find out, is it differentiable or not? Particularly we need to show that it is not differentiable. Let's see how to do this. Find out left hand derivative at 3. So in this way you can write this: limit h tends to 0 f of 3 minus h minus f3 upon minus h, right? So limit h tends to 0. Now from the left hand side it is minus x plus 3. So minus x plus 3 minus f3 is what? 3 minus 3 is 0, right? If you put 3 here, so it will be 0. Okay. Upon minus h. So this will go out and you will be left with limit h tends to 0 minus h upon minus h, which is 1. Okay. Now find out the right hand limit f prime 3. Okay, 3 plus. So this will be limit h tends to 0 f of 3 plus h minus f3 upon h. So it will be limit h tends to 0. Now from the right hand side it is x minus 3. So minus 3 upon f3 is 0 minus. I think I have done some mistake here. Let's see. So f of 3 minus h, right? F of 3 minus h. So it will be minus, so minus x plus 3. Yeah. Okay, so this is plus, right? Here you have plus. Yeah, that was the mistake. Let me write this again. Here the expression is plus h. So it is plus upon minus h. So your value is minus 1 here, right? And here what you have, here 3 will go out, this, and you have h upon h is 1. Okay. So this is the right hand derivative. Right hand derivative value is 1, but the left hand derivative value is minus 1. They are not equal and hence the function is not differentiable. You can check the calculation and do it for yourself. This is the way you have to do it. Okay. Let's move to question number 3. It says, check the differentiability of function f(x), x sine 1 upon x when x not equals to 0 and 0 when x equals to 0 at the point x equals to 0. Again, what you have to do, find left hand derivative. That will be limit h tends to 0 f of 0 minus h minus f0 upon minus h. Find this out. So it is f of minus h. So put minus h here, sine of minus of 1 by h, and f0 is 0, right? So, and here you have this. Now limit h tends to 0, sine minus 1 upon h does not exist. Does not exist. If you have seen my continuity video, we have said that this function is not continuous as well. So it is not differentiable in any which ways, but still if you want to prove using the rules of differentiability, this is the method you have to do this. So we have showed that the left hand derivative does not exist. Now we have to do the same thing for the right hand derivative. Limit h tends to 0 f of 0 plus h minus f0 upon h. So limit h tends to 0. Put this 1 upon h minus 0 upon h. So this will cancel out. Again, this expression does not exist. Since the left hand derivative and right hand derivative itself does not exist, the function is not differentiable, right? From the continuity point of view also, you can say that since this expression is not continuous, that also implies that the function cannot be differentiable. Now it's a good problem. It says that a differentiable function, it basically says a differentiable function satisfies f of x plus y is fx if y for all x. Then we have to find the expression for fx. For this, what you have to do, start with the definition of f prime x. It is limit h tends to 0 f of x plus h minus fx upon h, right? Now what we will do, instead of this expression, write in this form fx into fh minus fx upon h. Now take fx common from here. You have fh minus 1 upon h. This will be limit h tends to 0. Fx is as it is. Now what will this expression be? This is fh minus 1 upon h. If you look carefully, it will be f prime 0. Why this is so? If you follow this, f prime 0 is f of 0 plus h minus f0 upon h. So fh minus 1 upon h. This is what you have here. So this is f prime 0. So what we got from this thing is that f prime x is limit h tends to 0 fx into f prime 0, right? Now what you have to do, put x equals to 0 all through. What you will have, f prime 0 is f prime 0 whole square, because this is also this is basically, yeah, f0 into, oops, sorry, just a minute. This is fx into f prime 0. So what you have to do, this is f0 into f prime 0. Have I done it right? f0 is 1 and f prime 0. So okay, let me start from here again. If prime x is this expression, right? Now if you put 0 here, you will have f prime 0, and here f prime 0 squared, right? Okay. Right? Okay. Now f prime 0 squared minus f prime 0 is basically 0. So what you can do from here, take this common and you have this. So f prime 0 is either 0 or f prime 0 is 1. So either you have f prime 0 to be 0 or you have f prime 0 to be 1, right? What does this expression imply? If you look carefully, this expression implies, okay, I got my mistake here. This is fx, right? Yeah, let me check that again and I'll let you know. So here if you see, f prime 0 is basically 0. It means that the slope of the function at the point 0 is 0. So it means that fx is a constant function. it means that fx is a constant function, right? This expression means the slope of the function at the point 0 is 0, so it is a constant function. And here if you see f prime 0 is 1, let me write this, f prime 0 is 1. What does this imply? This basically implies that f prime x is fx, because if you put 0 here, you will see f0 is 1, so this satisfies. Now what you can do, fx upon fx, this is 1. Now if you integrate both sides, what you will get? You will get ln of fx is x plus c. If you know the rules of integration, you will know this. If you take integration both sides, you will get this. Now take exponential both sides, so you will have fx. So e to the power log x is fx. I hope you know this. E to the power log x is just x. So I am applying that here. So e to the power ln of fx is just fx. Right? Write this, and here you have e to the power x plus c. So it can be written as e to the power x into e to the power c. So this is a constant term. So suppose it is some a into e to the power x, right? So we got fx is a into e to the power x. Now we need to find the value of a in order to find this functional form completely. Now you know that f prime 0 is 1. F prime 0 is 1. And if you find f prime x, what will that be? This is as it is. Put 0 here. So f prime 0 here will be a into e to the power 0. E to the power 0 is 1, so it is a. So a, the value of a is 1. From these two things, you can conclude that the value of a is 1. So what will be the functional form? The functional form is fx is e to the power x. Here a, the value of a is 1, so this implies that the functional form which satisfies this criteria, the functional form that satisfies this particular criteria is e to the power x, or the exponential function. I hope this is clear. If you have any questions, you can let me know. Okay, if I get any other process of solving this, I will be posting that. Now, moving on, next we have some examples of differentiable function. Every polynomial function is differentiable. Every exponential function, logarithmic functions, trigonometric functions, and hyperbolic functions. So these are examples of some differentiable functions. Again, some non-differentiable functions. Mod x. Mod x is not differentiable. We have also, solved a problem on x, mod of x minus 3. So we have shown that the function is not differentiable. So this is not differentiable. X plus minus mod x is not differentiable at x equals to 0. Box functions are not differentiable at every integer, because at every integer they are not continuous, which we have proved in the previous session in the lesson of continuity, that box function is not not continuous at every integer point, so they are not differentiable also in those integer points. And we have just saw that x sin x is not sin 1 upon x is not differentiable at x equals to 0, and cos 1 upon x is not differentiable at x equals to 0. So this will come handy to you. Okay. Now after that, what we will do, we will see this derivative of different sorts of functions. Firstly, we have derivative of composite function. What are composite functions? A function which is made up of two or more functions is called a composite function. For example, here you have an example. Suppose gx is a function which is in the form 2x plus 1, and hx is a function which is x cube, and fx is a composite function in the form 2x plus 1 cube. So what you can write, so if you look carefully, it is a combination of these two functions. So we write it in this way, h of gx. So it is basically h of gx. If you do this, so h of gx is what? 2x plus 1, and hx is basically x cube. So if you put h of 2x plus 1, you will get back this expression. So fx can be written in the composite manner using the functions h and the function g. Now how will we find the derivative of these sort of function? Right, so we need to find df dx. What will that be? For that, we have to use something called the chain rule. You probably might know this rule, but let me revise it with you. So you want to find out ddx of fx, so ddx of h of gx, ultimately ddx of 2x plus 1 cube. So what you will do, first take the derivative, consider it to be a single thing and take the derivative. So 3 2x plus 1 and it will be 2, and then move inside this function and take the derivative of this expression with respect to x, and that will be 2, right? So 2x derivative is 2. So this will be your answer, 2x plus 1 square. And this is the definition of chain rule. You can take a look at this. If be a real valued function which is a composite function of two functions u and v, so if it can be written as v of u, then what you can do, you can take another variable t which is equals to ux, and then what you can do, if both these expressions exist, then df dx can be found out in this fashion. This is exactly what we have done here. So df dx will be dv dt into dt dx. This is the chain rule. Let me solve another questions with you so that it gets more clear. If x is sine x squared, so if you want to find the derivative, it will be firstly ddx of sine x squared. So the derivative of sine is cos. Write it as it is, and then go inside and take the derivative of x squared, which is 2x. So your answer will be 2x into cos x squared, right? So this is your chain rule. This is your answer. Okay, the second part will be the derivative of exponential and logarithmic functions. Exponential function derivative is pretty simple. It is as it is. ddx of e to the power x is e to the power x, and derivative of log x is 1 upon x. Now let's solve some questions using this. Okay, so you have the function to be y is e to the power minus x, and you want to find dy dx. What will that be? So the derivative of e to the power x is e to the power x itself, and then you have to go inside and apply chain rule to find the derivative of minus x, which is minus 1. So your answer is minus e to the power minus x. So it's a very, very basic question. Let's do question number 7. Y is e to the power cos x. So what will be dy dx? So e to the power cos x will be as it is. Now take the derivative of cos x. It will be minus sin x. So your answer will be e to the power cos x into sin x. Right? And these are some homework questions for you. You have multiple questions. They are good level questions. So try your hand at this. If you find it difficult, you can let me know. And this will give you more clarity in this concept. Okay. Now let's do some questions on logarithmic derivative. So the question says differentiate this expression. Now if you apply u by v method, it will be a huge messy thing. So we can't do that. Taking logarithm is the only way out here. So suppose this expression is equals to y. So what you can do, you can take log y and log of this expression. So what will that be? The square root will come out to be half, and then you have log of x minus 3 plus log of x squared plus 4. Then you have minus log of 3x squared plus 4x plus 5. I hope you know the rules of logarithm. If you know, you will find it simple. And then what you do, take derivative entirely. So what is derivative of ln y? It is 1 by y. 1 by y into dy dx. Right? You are taking the derivative with respect to x. So first take the derivative of ln y, which is 1 upon y into dy dx. And what will be this side? Half will be as it is. Here you have 1 upon x minus 3. So ln of this is ln x is 1 upon x. So that is the formula. Then you have this, and you have to apply the chain rule to find the derivative of x square, which is 2x minus 3x square plus 4x plus 5. And again take the derivative of this. This will be 6x plus 4. Now what you have to do for finding this, you have to
take this y right hand side to the right hand side, and y is this entire expression. So dy dx will be entirely in terms of x. You can't have y here, so do that. Y is root over of x minus 3 into x squared plus 4, I guess. Yeah, 3x squared plus 4x plus 5, I think. Yes. And then the entire thing, and it is divided by 2 here. So do that. So half will be as it is. Then you have the expression for y, and then you have everything in the bracket. So this term will be there, this term will be there, and this term will be there. So if you see, entire thing will be in terms of x. And your dy dx has to be a function of x only, nothing else. So that is your expression. This will be your answer. Write everything you have here and substitute the value of y here. Okay. Now this is a simple question. Y is a to the power x. Again take log. So this will be this. Then take the derivative 1 by y dy dx. And then you have this is log a. So this a is independent of x. So it will be as it is, and the derivative of x is 1. So what will be dy dx? Dy dx is take this y here, this, and then substitute this y. This will be a to the power x ln a. And this is sometimes we use as a thumb rule that if y is a to the power x, then y prime or dy dx will be a to the power x into ln a. Sometimes this is given as a formula, as a rule of thumb. And this is the way you can derive this formula, right? Okay. Let's move to question number 10. X sin x. Let y is x to the power sin x. Take log, so sin x into ln x. Then take differentiation. The process is the same, and here you have to take the uv method. So keep this thing intact and take the derivative of this first, plus keep this thing constant and then take derivative of this, right? This is the uv rule which I have described beforehand. If you don't remember the expression, you can pause your video and go back and see again. Take this y here. Y is nothing but x to the power sin x, this, and then you have this entire expression intact. Ln x into cos x. I hope you understood the process, and this is the final question I want to do with you. It's a good question that we have to find dy dx. Y to the power x plus x to the power y plus x to the power x is a to the power b. Now how will you solve this kind of questions? This is also solved using chain rule. Let's see how to do this. So here consider these to be separate functions. Suppose I write ux. I consider ux to be a function which is equals to y to the power x. Then I consider vx to be this x to the power y, and I suppose wx to be x to the power x, this function. So take these three to be separate functions. Then what you can say from here is that ux plus vx plus wx is equals to a to the power b. That is what is given here. Now if you take differentiation with respect to x, what you will get? Du dx plus dv dx plus dw dx. This is 0. Why this is 0? Because this side is independent of x. So ddx of a to the power b will be 0, right? This is a constant term. So for a constant term, there is no change in the value, right? So the derivative is 0. Now what you have to do, the only thing here is left to do is find out these expressions separately. So calculate du dx, calculate dv dx, and calculate dw dx. Let me do that for you. What will be du dx? So here you have y to the power x. U is y to the power x, and you need to calculate du dx. So firstly take log x ln y, right? Now this will be 1 upon u du dx. Now this will be x into 1 upon y into dy dx, plus this will be ln y, right? You are taking derivative with respect to x. So what will be this expression? So here you have du dx. Take this u on the right hand side, you will have y to the power x into this expression. Um, dy dx plus ln y. Right, now you have to do the same thing for v. V is what? V is x to the power y. X to the power y. So take log again. Log v is y log x. Now take differentiation dv dx. This will be y into 1 upon x plus ln x into dy dx, right? So what will be dv dx? Dv dx is, put this v here, so x to the power y into y upon x plus dy dx into ln x. Okay. Now the final thing is w. W is x upon x, I guess. Let me check. Yeah, it's x upon x to the power x. So take log x ln x and do the derivative. This is x into 1 upon x plus ln x, right? This is 1. So dw dx is nothing but x to the power x 1 plus ln x. So what you get here is that, so you got dw dx here, you have du dx here, and you have dv dx here. Now what I have told you is that the sum of these three expression is 0. So you have to just do that. You have these three expressions, just sum them up and put that equal to 0, and from that you will get the expression of dy dx. Let me do another step for you. Du dx plus dv dx plus dw dx is 0. So what we have, y to the power x into x upon y ln y plus dy dx plus ln y. Dy dx plus ln y. Then you have here x to the power y upon x plus dy dx ln x, plus you have this expression, so x to the power x 1 plus ln x. Now if you see this expression here, you will see that you have only dy dx terms, dy dx, and these are equals to 0. This is an equation, right? So these expressions are equals to 0. So if you take dy dx common, so you will have some expression here. So here you have to arrange this. So do this for yourself, that it will be a messy looking term, but this will be entirely in terms of x and y, and you have to just take dy dx common here, and you have to write this ratio, and this will give you your answer, right? So thank you so much for watching this video. I hope you find this helpful. I have described every aspect of differentiability. I have solved multiple questions with you. If you have any doubt anywhere, any question, you can let me know in the comment section. And if you like my video, give me a thumbs up and do subscribe to my channel. I am putting a lot of hard work for this, and stay tuned for the next video where I will be teaching you concavity, convexity, quasi concavity, quasi convexity. So until next time, and thank you for your time.